Hello, my name is Alejandro Salas, and this is me explaining my application for my final project in my AI class. So for this application, what I created was a program that could detect objects in a picture that you feed it through. So the objects that I'm trying to detect for this certain application are cars and trucks. So I manipulated this program so it can detect just that. And the way this program works is that you give it images and then it will return the image by with the boxes around the detections that you're trying to detect in the image. I also manipulated this application so it gives me a counter of how many detections are set in each picture, and this program itself runs 3 images. So let's run the program because it does take a little bit of time for the whole app program to run since it is 3 detections that it's trying to run. It's 3 images. So while this program is running, and yeah, the console gets a little bit messy with all these warnings and stuff, but I'll explain the why of this project, of this program. So this software will be used on my SIP. For my SIP, I'm trying to create a software that can detect the cars, the amount of cars waiting in the commercial lane in Tecate, Mexico. That's for my SIP. And this is the same methodology that I will be using that I will be applying in my SIP, because basically all I need is counting the amount of cars in the commercial vehicle lane at one point. So we're just waiting until I get the results from the detections that are trying to run. It will be here in a second. While we wait, you can see that the images will be image new and image new 2, image new 3. And we got back the results, and we can see that in picture number 1, the amount of cars is 21, and in picture number 2, it's 17, and for picture number 3, it's 17 as well. So if we pull up the pictures, we can actually, I'll show you a comparison of side by side what these results and pictures look like. So as you can see, this is a picture of the UAT parking lot taken from my dorm. And when I run this image through the software, I get results that look something like this. I'm satisfied with the results that I'm getting from this application. It's counting almost all of the cars in the parking lot. Only one's missing, and that one's this one, which is being obstructed by um, a bush. We can see in the next picture that this is the this will be, sorry about that change, but this will be the picture that I ran through the application, and once I ran it, I get results that look something like this. Again, I'm quite satisfied with the results. Almost all the cars were detected except this one, which is again obstructed by a bush. I'm guessing this AI does not like bushes or something like that, but I'm just gonna have to work around that in my SIP app integration. This is the final picture. I wanted to play around with the angles a bit, and this is what I tested in this picture. And I get results that look something like this. Again, the cars behind the bushes are not going to be detected, but that's a common theme. But something that I really like to point out is that this car down on the back here is being detected, and that's super important because for my SIP, I'm going to have cameras that are somewhat like this, and the actual commercial vehicle lane works in the rows. So the vehicles are going to be aligned in somewhat of this format. So the fact that this car is being detected is super good. Anyways, that's been my application. That's what it does. Sorry about that, my mic just went out. But yeah, that's the functionality of my project, and I just had so much fun implementing all this into a Python project. And yeah, that's been my project. Thank you so much for your time and attention.